order. There we go. The first item of business, as always, is approval of the last meeting's minutes. That was from April 27th. And if we can have someone raise their hand to make a motion. I've got Joe Slavnik making a motion. Is there a second? And Rich Salerno. Can we put that up for a vote, please, Dina?
Awesome. The motion has passed with 4 abstentions.
Okay, thank you, everyone. So with that out of the way, let's proceed into our presentation. Stephen, would you like to introduce Greg and then Christine?
Yeah, well, I'll introduce each as we move into our presentation, but thanks to all the members. You know, I was overwhelmed with the response we got for people who were willing to step forward and speak. So now we have speakers out to April, I think, of next year, given the annual meeting in February. But our first speaker is our own Greg Ulrich from Village of Carroll Stream, and he is going to be talking about the Kimberly North Stormwater Study. This item is of, you know, I think this flow component is of big interest to the DRSCW. We're typically focused, you know, we got the habitat and the chemical variables down that control for aquatic life. But this flow component, as we know from earlier presentations, notably from the Sustainable Streams presentation on the fact, you know, that flow figure where bed material would become suspended, and that he had found that that was linked to a medium-term IBI values. So with that, I'm going to hand over to Greg. And Greg, I believe you're giving this presentation again later today, so you're getting to do your dramatic version on us. Greg, you're muted.
Not a good start. Excellent. Thank you.
Yeah.
Yeah, so it's going to be at the 2022 Illinois Collection Systems and Stormwater Conference. So it's actually started this morning. It's kind of an all-day conference. It's down at the NIU campus. So I've got the afternoon presentation. When I saw this came through, I said, "Oh, hey, I get to practice here in the morning at my desk."
Yeah, I hit you up earlier about it, but yeah, you're up.
All right. So yeah, we call this the Kimberly North Stormwater Study. That's just the name of the subdivision of particular detention basins that were part of that subdivision that are, you know, not operating ideally. They're undersized. So we hooked up with Geosyntec on this. Rishabh is the project manager on that because I you know, did this volunteer last minute, and he was in Wisconsin Dells when I did that volunteering. I told Rishabh I will take his slides for him. So it's just going to be me today, and we'll move on. So we'll do a little bit of background. We used EPA SWIM. That's where Rishabh normally would talk. And then this is going to focus on what I'm terming smart stormwater management, and then we'll wrap up with some conclusions. So Carroll Stream is, I think, kind of unique, and it's relatively young, and we started early with stormwater management. So I just wanted to show that history. Majority of the village is in Klein Creek, and the study area of Kimberly North is a small subset of that. So with what Geosyntec did for us, they were doing, you know, a traditional approach, and we were using ISWS's bulletin 70 and 75, but we're still kind of working through those conclusions. But in the meantime, I worked with students from the University of Illinois at Chicago to investigate this May 2020 storm event as part of their senior design project and using some smart technology. So this presentation is sort of a rehash of what they did for their expo. And then I'm just gonna touch briefly on the use of water level loggers for our calibration. So starting off with the history here. So the village was incorporated in 59. Then in 72 was a pretty major flood event that, affected Naperville as well. And there was an Army Corps of Engineers study that was done. And, there was flooding before then, but that one really kicked off a lot of stuff. So you have in 73 following up with a village-wide stormwater study, and that's included a recommendation to enact an ordinance to implement stormwater requirements for private development. Then the FEMA got effective, and then in 87, it was I think I've seen the term flood of the century used. I was living in Carroll Stream at that time, and I remember riding my bike through the floodwaters. And that, kind of kicked off DuPage County working on a county-wide ordinance that happened in 1991. But, as part of that discussion, there was a memo that was put together as to what has Carroll Stream done, towards flooding. And that included counting up all the cumulative detention that had been created by private and public development since then. And that was, 1,400 acre feet, which is pretty significant. So even before the ordinance, we had that much in place. And then DuPage County did the Klein Creek watershed study, and that recommended some, regional facilities. And they knew phase one was, going to be in that study. So they got started on that sooner. And then we did this phase two, which is Gary Kehoe Reservoir, that ended 124 acre feet. And then most recently is the Armstrong Park flood control reservoir that happened after these 3 relatively back-to-back major 100-year events. So I just marked that Bulletin 75 came out in 2020. And then this May 2020 event is just kind of that flood event there. That's not 100. We'll talk about it. Talk about what size that was for us. So over on the right is just that's Klein Creek watershed. So you've got Stratford Square Mall at the upstream end. That's in Bloomingdale, and then you kind of cross over Army Trail Road, and most of this is Carroll Stream, and a little bit of Glendale Heights to the right. So that boxed area is what I have on the screen to the left. And, everything is flowing from right to left. And then the main stem is there on the left-hand end. And the circle is those detention basins as part of the Kimberly North subdivision, which is what we are talking about. So when that subdivision was developed, everything upstream of it was pretty much agricultural. And then over the years, that developed, and we have, as many as 10 stormwater management facilities that are upstream and tributary to these 2 detention basins. So you would think that would help, and that we wouldn't be seeing the issues that we see today, but obviously that's not the case. So then we used, as I said, EPA SWIM, and so I don't know if you had paid attention earlier as to, the density of the storm sewer network is pretty decent in this area, being urbanized as it is. But if you look at the blue lines, we, skeletonized that, storm sewer system and simplified it to just enough to get the conveyance modeled. But it's also more than just taking the detention basin and dumping it to the next detention basin. We did want to take a look at, what happens in between. And the study area is about 110 acres. So then zooming in, the detention basins are kind of split between what I call 2 lobes. They each have their own address because they're privately owned, but they more or less operate in conjunction with each other with a 12-inch equalizer pipe underneath that access driveway. And everything flowing from right to left means, the emergency overflow on the left end and spills over into the railroad tracks. And then the restrictor pipe, which is kind of ironic here, is an 8-inch pipe that's underneath the railroad tracks, which makes future solutions, you know, a little bit more complicated than normal. So then before I move on, so looking at those lobes, that's the May 2020 flood event. So you can see that the access driveway is flooded, and then in the west lobe in the background there, that's it overtopping the weir. So this is the flood events, or this is the USGS rain gauge that's at our water reclamation center, which is fairly close, a couple miles away. So it's something that I like to use a lot in my analysis. So over these 5 days, you can see that we got 6.3 inches. If you put that into Bulletin 75, it's about a 10-year storm over 72 hours. If you zoom in into the 24-hour period, that actually comes down, and it's only a 5-year occurrence. But then if you zoom in again as to that most intense period, about 2 hours where we got just under 3 inches, that's back up to a 10-year storm. So, you know, it's not, you know, it's only a 10-year recurrence interval. So why is this emergency overflow weir overtopping? That's kind of what we're trying to get at with this. So that's basically the time of the storm when I took that picture. And just finally, I wanted to touch on kind of like a sort of an ancillary topic, which is the fact that several years ago, when I first started with Carroll Stream, I knew I was going to be doing some studies, and I wanted to get some data on our detention basins and how they operate. So we ended up purchasing just over 24 of these water level loggers, and have deployed them in a couple locations in Klein Creek, and as well as on stormwater detention basins throughout the village. And so what that looks like is really pretty simple. These are relatively cheap. And then you've got in the upper left, that's one of the lobes. And I just took a PVC pipe, drilled some holes in it, and pounded it into the ground. And then I've got a typical well cap. And then the water level logger is just, you know, hanging off that well cap like it would in the groundwater. So then you can see here is just a simple graph of the sensor depth for March through November, which is when I deploy the water level logger. And then the rainfall from that USGS rain gauge is in the orange. And you can see it's, you know, correlates pretty well. And then you can see our May 2020 events in comparison to the rest of the year. So then this is what Risha would have, you know, stepped in on, and I'm just gonna kind of shoot through this a little bit quickly. So we used EPA Swim because I wanted to be able to play with this later. So I needed the freeware version. So we did end up using the hydrology that's built into EPA Swim, which is not something I'm necessarily familiar with. And that was a good learning experience. So moving on, they use the digital elevation model from that data that's available from DuPage County's LIDAR efforts, and then they, you know, burned in the sewer network so that it, you know, dictates where the flow goes. And then they use that to delineate their subwatersheds. So the idea was kind of to set up a process, knowing that this was just a small portion of the Klein Creek watershed, and that we were hopefully going to do more of this throughout. So this is the translation of the subwatershed and the sewer network into the SWIM model, and they used some Python coding to do that more efficiently. And that's just an open source Python script. So the subwatershed impervious is represented by these subcatchments. They used the green amp function within EPA Swim model for that hydrology aspect. And then we were able to put in not only the May 2020 storm, but then we also, you know, looked at the Bulletin 70 and 75 I said earlier, we're still parsing through those conclusions. So when comparing the model to the water level logger data that I showed you earlier, we found that through calibration, it models it pretty well, I think. And there's a bit of a tail end. So the brown is the real life version. So it's draining slower than what the model is saying. And I think that has something to do with the operation of that 8-inch underneath the railroad tracks. But in general, I was pretty happy with how that model came out. So, their study is going to look at, the traditional solutions. We looked at adding more storage within the watershed, and we looked at potential, that might also include a pump station if it's below the outlets. But then the other thing that EPA SWIM allows us to do is use control rules, and that can look at certain things like the proprietary Opti system that looks at real-time controls and forecasting, and then and sensors and changing the restrictors based on that function. So, we're not trying to sell Opti. It just happens that, and Rishabh could have talked to this a little bit better than I could, but Opti was started by somebody that began in Geosyntec and did that as a special project within Geosyntec, and then sort of developed that into his own company. So that's kind of why we mention it. So then this is back to where I wanted to focus specifically on the smart stormwater management. So show you what the EPA control rules do, what did the May 2020 event look like, and how does it affect the storage utilization? So when we talk about smart restrictors, I'm basically just saying that the restrictor is not just a hole in a plate, that it's now a valve that we can open and close and increase and decrease the flow. And that's usually that actuated valve, and then it's controlled by a control panel that's, communicating with, systems in the cloud and machine learning and all the SCADA, and that's also listening to the level sensors. So within EPA SWIM, this is the help format. So it's really pretty basic. You're just creating a rule with if, and, or statements, and then and else logic. And then the conditions, there's certain conditions that you can, you're limited to, but they're pretty extensive for what we need to do. So an example is we called, this is taken out of the actual model. So rule 245A is right there up at the top. So we said, basically, hey, if the simulation date is before May 15th, which is basically before it started raining, then just before it started raining, then close it to 30%, 0.3. And then else always have it open, right? And you can see in the next one, rule 319, we made it based on the head or the water elevation that's within that detention pond. So node 319 is a detention pond, and then we said, hey, if it's greater than an elevation, then this is what your orifice settings should be. So moving on, this is then the output for the existing conditions. And so you'll see with this 10-year storm in the west lobe only, that emergency weir was at 782.30, and the water elevation just got over the top of that. And then the cyan is showing you what that flow is with the scale over on the right. So pretty decent flow over the weir. And that happened not only during that first event, but later on May 17th when that other rainstorm came through. All right, so what I had the senior design group do was put controls on all 10 of the stormwater management facilities, and it was a pretty basic control. It just said close the restrictor before it rains, and then when the rain is done, open the restrictors back up. And so that's just because we could Monday morning quarterback it knowing what the storm did. We just kept it as simple as that. And so you can see that going from having a pond that was full in the existing conditions and didn't quite empty till May 20th. What you now see with controls on all 10 is that it emptied multiple times. And, so that's a significant reduction. And obviously it didn't overtop in any of those bursts of rain that came through. So then what I had them do was look at, well, do we have to do all 10 or can we do this on some of the bigger ones and just a few of those? So we said, okay, let's just do it on the 3 largest stormwater management. So once again, still very basic real-time controls, and just said, keep it closed and then open it when the rain is done. And you can see that that's, not too bad. It's obviously kept it from overtopping, so that's good. And, it drains relatively quickly. And so, with just 3 of those being controlled in a more smart way, what we're doing is utilizing our storage a lot better. So this is a focus on, what is the storage utilization? This is just a printout from EPA SWIM, and it'll tell you what's the max storage that occurred during the time period that you were analyzing. So it's a little bit misleading because it's going to look at the storage. If you have an emergency overflow weir, you have to create like this dummy. You have to have the storage go above. So when the head is shooting out the emergency weir, you've got, something containing that water. And so it's including that in the storage. So what that means is that we're actually overtopping when we're at 80% of storage capacity. And so when you're at 91% here and 82%, that means the emergency overflow weir is actually active. So it's pretty full, obviously. So then you look at those 3 large stormwater management facilities that were upstream, and you can see that they're mostly empty. Only 319 was more than half full at any point during that storm event. Okay, so then, looking at when we add those very simple controls, which just say close the restrictor and then open it when it's done, you can see that the utilization is flattened and evened out across all the different ponds. And so you almost double the utilization at that 550 center and the 465. And you're being more efficient with the infrastructure that you have. So in conclusion, I think that someone would find that the control rules are actually fairly easy. It's not too major of a coding to do that. That smart stormwater management could have eliminated flooding on that May 2020 event. So all we did was use existing storage and the same conveyance infrastructure. All we did in theory was retrofit the restrictors. And with that, the utilization rate, by volume, was nearly doubled during that storm event. And so it's likely that, its maximum effectiveness is going to be these 10 to 25 year recurrence intervals. Obviously, that's a guesstimate statement that I'm making, but that's my gut feeling. But honestly, that is what, people see. And if you're talking about urban stormwater flooding, that's what people see, is that those more frequent events. And so when they're frustrated by those and you can resolve those, I think that you can make a pretty big impact on people's lives. So that's not quite DRSCW focused, right? That was more of my basic presentation. So I threw in this last slide also to kind of help with the fact that, okay, on the left is a map of all our detention basins that exist in Carroll Stream. The green are the private, the red are Carroll Stream Park District, blue, the village, and then there's the purple reservoirs that DuPage County has. So it's a lot of opportunity there. If all of these were smart to take a look at, how we can maximize it. So my long-term goal is to create what would be called currently as a digital twin of the stormwater management system. what I'd like to do is look at establishing a single release rate. So each one of these detention ponds are held to the DuPage County Ordinance is 0.1 CFS per acre. And that's just to, say what is the carrying capacity of Klein Creek, and let's keep each one of those to that rate. And, that should mean that Klein Creek then can maintain its capacity. If we were to do this smart restrictor, that might get violated, and that ordinance might get, rate might be exceeded, just depending on how it gets operated. So we want to look at, well, when at that star, that's when Klein Creek leaves Carroll Stream. So could we use that as a single release rate? So that's another step. And then the DRCW kind of focus is, as most of you should be aware, Klein Creek is got a stream bank stabilization project that the DRCW group is funding with some of the project funds, and that's going to go into construction in August. And the idea is, we're going to be spending a lot of money on the stream bank stabilization, and the village itself is doing a lot more in addition to just that one project. And the question is, can we also do this hydrologic modification and support, the stream bank stabilization that we are constructing, and also in a way, affect aquatic habitat that are, structural methods, may not be able to provide. And, this is kind of where we conclude, and then maybe Stephen, I'm sure you have some thoughts on it, but, so this is just our contact info, and then I'm going to make the EPA swim files available. You can click on that link, and if you wanted to download it and play with it and learn it, you can. And then the senior design project presentation, I just wanted to give a shout out to those kids. That's a taping of theirs if anybody wanted to watch it. So with that, I will stop sharing. And I don't know, Stephen, if you wanted to talk or.
Yeah, we have a couple of questions, but just before jumping into that, one thing, Greg, so this, as you're looking, you nearly doubled your detention capability, but how does that compare to the more traditional, cost-wise, to the more traditional approach of, digging some extra ponds or increasing the capacity of those ponds? I'm assuming that this dynamic aperture system is more cost-effective.
Yeah, certainly in the short term, because all you're doing is just replacing the restrictor. You're putting in some control panels, and then you're, adding some instrumentation, and then you're, connecting to some software. So then long term, you're going to have to operate that. And, that's going to have a long-term cost. But compared to the amount of storage that we would have had to put into the system, into this watershed to replicate that, I mean, it's magnitudes, factors cheaper than that traditional method.
And of course, the huge investment of staff time to organize and run all of that.
Yeah.
So one of the questions we had was, did the analysis start with the water level at the normal water level or the outlet elevation?
So the analysis, these are dry detention basins, and where the restrictor discharges is into a 21-inch storm sewer with pretty good pitch, and we're at the upstream end of the watershed. So we did not have tailwater effects, and I did not have, water in the detention pond. There was not any appreciable rain prior to that event. We do have all of May put into the program that we ran through. So in theory, you could have it start with whatever water was there to begin with, but that wasn't the case for that May storm event, so we didn't really need to do that. But tailwater is not an issue that we had to really focus on with this project. So hopefully that's maybe where their question is also going.
Okay. So you'd also look at the whole village, and you know, the just thinking about marginal improvements, it's possible that if the whole system was on this kind of practice, that the results would be even larger for each individual basin. In other words, that the sum of the total basin being working together could be larger than aggregating it for each individual basin if it was done in that way, if you know what I mean.
Yeah, I think so. But you know, the challenge is actually doing that modeling and proving that point, right? So that's the hypothesis.
So if you implement this and it works out well, then I guess that's the next step, right?
Yeah, right. So obviously the technical aspect is certainly a challenge. It's going to be a lot of work, you know, to put that in and get that modeling. But you know, we also have a political issue too. Most of those basins being privately owned and maintained. You know, we're going to have to, if we're going to include those in it, then you know, that's going to be an issue. But that's kind of why I was having the senior design group look at just the 3 largest detention basins, right? I mean, a lot of those private detention basins are these, you know, small developments. You know, they're small detentions because they're just that single property. So maybe those aren't as important for the system-wide discussion that, you know, that you're talking about. Maybe, you know, with the fact that most of those detention ponds that are large are owned by the Carroll Stream Park District or the village or DuPage County, you know, maybe we just need to do those.
And they may represent already, you know, 80% of the total actual storage, if not surface area.
Yeah. So.
Okay, let's see if any other questions. No, I think that's it. Well, thank you, Greg. And obviously, this is interesting to link this together with the other work that we're doing, as you pointed out, protects it, and then also, you know, if we can shave off some of those peak flows, that's we all know that what we don't know exactly what our values are to stop bad material becoming, but we know that it's being suspended at the moment, and so lower anything we can do to lower that is good. And obviously, this is a good. I said, you know, fiscally that we can produce a better result with our existing infrastructure than we have with than we're currently doing. It's a interesting analysis.
Yeah. So obviously we are concerned about flashy streams, right? And so could we reduce that flashiness? And so, you know, my question to you is like, you know, how much of an impact do you think we could make if you know, with this kind of smart restrictor, and how much do you think that plays a role into the aquatic habitat factor?
Well, one factor, obviously, of course, at the high end of flows, and we have erosion. But in terms of that flashiness, I have to admit, I don't know. We know that it does play a role, but I can't quantify it. I know you and I've talked in the past about trying to perhaps do some studies, and perhaps the work at Carroll Stream, and then also say on the Lower East Branch, et cetera, may be sites where we can start to think about doing some long-term analysis to try to work out about, you know, flows with suspension of that bed material. And then at least if we know what that figure is, then we could start to back from there and then start to try to track that out with our biological data and work out how much impact it's having. But yeah, you know, I can think about it in a theoretical way, but I don't have any, I have to admit, any guidance at the moment. I think anything I said would be very premature.
Yeah.
Sorry.
Right. Well, thank you. I appreciate it.
Thank you very much.
Yeah, thank you, Greg.
Okay, we're going to open up our second presentation. Okay, and our second presenter is Christine Wood. She is a water and waste water engineer with Donahue and Associates, and she is going to be presenting the microplastic monster. I don't think this subject is going to need any introductions. Obviously, one great interest to us. We haven't done a lot of work on it ourselves, given that we're neck deep in all our materials, but this is definitely in the area of emerging pollutants. And Christine's presentation is looking at microplastics in wastewater treatment, and I'm glad to see she's also offering some potential removal solutions. So Christine, thanks very much again for stepping in at short notice, and I'm turning the mic over to you.
All right, great. Thanks, Steve. Good morning, everyone. Thanks for having me here. I'm excited to talk about the microplastic monster, and hopefully by the end of the presentation, you understand why I'm calling them monsters. So just keep in mind as we go through this that it's a literature review and there's a lot of studies out there already. However, there's still quite a few gaps in our knowledge at this time. So here's a quick outline of what I'll discuss today. You'll see this pop up through the presentation as a guide, so you can kind of track with me. But I'll talk about the purpose of this presentation, kind of why I'm bringing it to everyone's attention. We'll talk about big picture, types of plastics, the concerns with these plastics and characteristics of them. And then we'll talk about microplastics and wastewater and, like Steve said, the different removals that we have going on. So first of all, the purpose of this talk is to bring awareness and start discussions on microplastics in the wastewater system. My intention is not to scare anyone. It's just a fairly new topic that I think is important to discuss and kind of bring attention to. So we'll talk about what microplastics are and why they're important to acknowledge, as well as the impact they have on treatment and what we can do about the management of them in the wastewater treatment plants. So the big picture of the plastic pollution problem. The EPA recognizes this plastic pollution problem as an emerging environmental issue. The problem impacts all aspects of the triple bottom line, which is environmental, economic, and social factors. So we probably can't go very far in today's world without using or seeing plastic. So unfortunately, society's dependence on our plastic products has accumulated on a large scale. And this accumulation causes things like the Great Pacific Garbage Patch, which is shown in the picture. And this is only one of the more well-known areas of plastic accumulation in our surface waters. And just this one doesn't look too bad in the picture, but it's actually 3 times the size of France. Big problem. And of this plastic, so 60–80% of the total marine debris is plastic, and 90% of what is floating is plastic. And overall, around 80% of this plastic comes from land in forms of urban runoff from our roads and our structures, our household products, and municipal wastewater, various industrial cleaners and uses, and even just simply littering or ineffective waste management. But of all the plastic accumulation that causes these global concerns, there's 3 main categories that the plastics can fall into. We have macro, micro, and nanoplastics. So macroplastics are your large scale, large size plastic products like bags, bottles, ropes, netting. Most of our plastics are macroplastics used on a daily basis. So we look at one step smaller, we have microplastics. These are produced smaller as microbeads, or they can be broken down pieces of a macroplastic. So you see a piece of a bottle floating around, that's going to be a microplastic. They can be seen by the human eye at about 5 millimeters. As a reference, that's about the size of my pinky fingernail. So it's small, but you can still see it, and it's not great to look at when it's around our environment. Go one step smaller, we have nanoplastics. Typically, these require magnification to see, but today's focus is obviously on microplastics because 90% of the plastics in the aquatic environment are microplastics. So their accumulation is the main contributor to our big picture plastic pollution problem. So even though this monster here might be cute, he is a microplastic monster, and it's the problem we need to bring awareness to in our communities. So microplastic monsters negatively impact our environment and have potential for human health concerns. So starting with the environment, it's damaging to our ecosystem and our wildlife through getting tangled up in them or ingesting them. It can block digestive tracts or diminish the urge to eat for animals, causing all sorts of issues with that. Another interesting thing is plastic can contribute to the bioaccumulation of contaminants. They can actually sorb to the surface of our plastics, which I'll get into a little more later. But ultimately, plastic can cause alteration of the ecosystem. There's also some evidence out there that Plastic additives on the surfaces of plastic can be endocrine disruptors, so causing issues with repopulation of our wildlife as well. But for human side of things, it's not just aesthetically unpleasing to look at when we're on our vacation on our beaches, but human health also can be negatively impacted potentially. So the World Health Organization, known as WHO, has classified microplastics as not being an immediate threat to humans, which is great. However, there's a severe lack of information available. So it's hard to say if that's really because of the research that we have, or we're just not sure what our risk and exposure really is to these microplastics. But because human health is generally a priority for us in research, the focus of microplastics right now lies in drinking water and fish consumption. So again, with that, we can see bioaccumulation of certain contaminants, which can be a concern for humans. We may be able to pass those plastic particles through our systems, but it kind of gives a vector for contaminants to absorb into our tissues in our bodies potentially. So WHO did state in a news release that the reduction of plastics being released into the environment will reduce human exposure and benefit the health of the environment overall. So now let's dive into what these microplastics really are. So they come in a wide variety of forms from different sources. So we can have anything like films, fibers, fragments, or microbeads. You might be most familiar with the microbeads, and you can see in the picture kind of what each of these different types of microplastics can look like. So for the two sources, primary microplastics are manufactured in small microplastics, so they come out of that manufacturer as a microplastic. Probably most familiar, again, the microbeads, pellets. These are in a lot of our cosmetic and cleaning products, anything with a little bit of abrasion, face washes, toothpaste, things like that. The 2015 Microbead Free Waters Act focused on phasing out the manufacture, packaging, and distribution of microplastic containing products, but they can still be bought and sold, which seems a little silly if we're aiming to remove these primary microplastics from the environment. However, there's another way that microplastics can be released into the environment, and this is through secondary microplastics. So these are created from larger pieces of plastic, so the breakdown or fragmentation of our macroplastics into microplastics. And this can happen through mechanical fracture, environmental stressors, or harsh conditions, like at a landfill. So both primary and secondary microplastics are of concern for the environment and are seen at wastewater treatment plants. So wastewater treatment plants are considered to be a point source for microplastic release into the aquatic environment, kind of like a last stop for removal before microplastics hit the surface waters and get very easily dispersed and are very hard to remove. So this figure here demonstrates the relationship between microplastics and the wastewater treatment plant. There's a lot going on here, but we'll just focus on the wastewater treatment plant and those specific sources and discharges. So sources to the wastewater treatment plant can include land runoff, especially when a community has a combined sewer system, municipal and industrial wastewaters, and landfill leachate. And every community and collection system is different, as we know. So plant to plant, this can vary quite a bit. Every community, social factors like waste management and recycling also play a big role in this variability. So you can see here the discharges from the wastewater treatment plant include our liquids effluent and our sludges from our wastewater treatment plant. So we have the direct discharge in our liquid effluent to our receiving waters. Thankfully, wastewater treatment plants, as they are today, do a really great job at removing microplastics from the liquid stream. So only about 1% of microplastics that are entering our wastewater treatment plants are being discharged through our liquid effluent. Awesome. However, then 99% of these influent microplastics end up in our solid waste streams. And with our typical disposals of land application and landfilling, we have various pathways that microplastics can enter the environment through our solids disposal. So you see a landfill, it can move then, not shown here, back to leachate, back to the treatment plant, or to the surface water or through our soils as well. Excuse me. And then a similar thing with land application, runoff through the soils, different things like that. So clearly focusing on the reduction of microplastic discharge can assist in the global movement to reduce the aquatic plastic pollution. But before we look at the removal of microplastics, we need to understand the properties of microplastics in wastewater treatment plants. Just in general, there's a high variability in sampling and characterization methods and studies, which makes it very difficult to get a good overall picture of microplastics and the influence of wastewater treatment plants and throughout their treatment unit processes. Every treatment plant can be different, and the studies out there reflect these variabilities. So the rest of the presentation kind of summarizes what's typical in literature. Again, every plant's different, so it's hard at this time with the research that is out there to say, this is really what we're dealing with, but it kind of gives a good summary, good introduction of what we may see at each different plant. So of all the different studies, there is about 30 different types of plastics that have been identified in influent wastewaters. And two of the most common are polyethylene and polypropylene. So these two types of plastics are used in almost anything you can think of, bags, bottles, bubble wrap, netting, buckets, even like construction sheeting and packaging film, or food packaging. So both of these, though, have high uses in microbeads or micropellets and apparel fibers. When you're washing your clothes, small amounts of the fibers get released into your wastewater. But these plastics come in a variety of forms, as we saw before. But the pie charts on the right is shown in your sludges, you're typically seeing fibers most of the time, and in your liquids side of wastewater, you get a lot of flakes and fragments. You have to understand what we're looking for to be able to accurately measure it in our wastewater treatment plants. And there's a lot of research being done on microplastics, but there's still a lot to learn, and hopefully those methods can be more refined and we can get a better understanding of knowing what we're looking for, and then that helps us be able to understand what we're removing. But I think this is a great picture that shows the variability of microplastics in wastewater. This is from a single study of a single sample of microplastics in a wastewater influent. So the top two images, A and B, are primary microplastics. So your microbeads, your micropellets from personal care products. The bottom two, C and D, are secondary microplastics. So this is what fragments or fibers can look like in your wastewater treatment plant influent. So the characteristics of microplastics impact the removal efficiencies. Anything like plastic type, density, texture, shape, and size, really everything except for color seems to have an impact on how well these microplastics are removed by different unit processes at the treatment plant. But to understand the life of a microplastic throughout the treatment train, it's helpful to know some additional properties of them. So first off, they are hydrophobic, meaning they prefer to float or settle in the solids anywhere they can be, not in the bulk water. So even kind of attaching to surfaces of equipment can be seen as well. But primarily this is an issue because they like to accumulate on flock particles, which for operators, this can change the settling properties of your flock, decrease treatment efficiency, or make predictive calculations of your settling processes challenging. Also, as I mentioned before, the contaminants that can sorbit the surface of microplastics, anything like PFAS, heavy metals, PCBs, things that we're already struggling to deal with through wastewater treatment and our water environment, can attach to the surface of microplastics. A lot of microplastics have a polarized or kind of charged positive negative surface, which can help these contaminants attach to them, making them more difficult to remove, increasing their mobility in the environment in a different method than just the bulk water. So this can be troublesome in working on removing these other contaminants that we're struggling with. There was just a study that was shared with me that I saw that viruses are also something that can attach to the surface of microplastics. They have, I want to say, about a 3-day lifespan on those microplastics. So once they're discharged from the wastewater treatment plant with these viruses, they can wash up on our beaches, be accidentally ingested by humans or wildlife, and kind of increase that spread of viruses as well. But that's a whole nother topic I could talk on, a whole presentation. But so continuing on, biofilms can form on the surface of microplastic. Makes sense if we think about attached growth treatment processes. But this is another way that treatment efficiency can be decreased by microplastics in the wastewater, especially troublesome with disinfection and making sure we're getting full disinfection of our treatment. And so microplastics are a concern on their own, but they bring operational challenges for traditional wastewater treatment plants. And the last thing is macroplastics can break down to microplastics. Microplastics can break down to nanoplastics. So as these microplastics are moving through the treatment processes, fragmentation can happen. If you think about having one big microplastic moving through your treatment plant and it hits a mixer and a pump or filters, they can break into two. And now we have two smaller, potentially more difficult to remove microplastics to deal with. So fragmentation is a big issue in the treatment plant as well. Because of this fragmentation, a mass-based mass balance for microplastics seems to be more accurate in kind of characterizing and having a balance of microplastics through the treatment process. So you have your influent amount of microplastics coming in, and those will be removed from your liquid stream and go into your sludge. So ultimately, the amount of plastics in your liquid and solids discharge will equal the amount of the influent. So if we're looking at just plastic pieces, as these break up and fragment through the system, that can make it difficult to accurately describe how much microplastics are being released and introduced. So the next thing to look at really is removal of microplastics through wastewater treatment. So conventional treatment and tertiary treatment will remove our microplastics from our liquid stream, and then we'll also look at solids processing. So let's start with conventional treatment. As I mentioned before, wastewater treatment plants do a great liquid stream already, but they're not necessarily designed to remove microplastics. So conventional treatment can remove anywhere from 71 to 99% of microplastics, depending on your unit processes, plastic characterization, and different things like that. So typically the removal is around 90% for conventional treatment, and the main mechanism responsible for moving is settling of particles due to the difference in densities between microplastics and wastewater. So for pre-treatment, looking at our screens and our grit removal type processes, more of your larger microplastics are removed here due to those density differences, as well as just getting trapped in other solids that are getting removed in those stages. So if we look at primary and secondary treatment, the biggest mechanism for removal here is density with our laminar flows through these processes. It drives the removal of capture of these microplastics either in the sludges or the scums in these unit processes. Disinfection is a little different, especially with processes like UV light. There's shown to be a fragmentation of microplastics, which breaks them up into smaller pieces, but doesn't necessarily provide removal of them. Chemical interaction is still something that's going on in research, hasn't been clearly defined yet between microplastics and our chemicals that we're typically adding, specifically for the types of chemicals, the concentrations, and the retention times that we're seeing. So that's still up in the air a little bit. Every plant's a little different, and all microplastics might react differently with the chemicals you're adding. So this table here kind of gives an overview of a couple different unit processes and their removal efficiencies. So kind of give you a second to absorb that, but the figures on the left side of your screen are primary effluent microplastics, and on the right side are secondary effluent. So pre and primary treatment has the most impact on removal, and primary treatment sedimentation, we can have anywhere from 50 to 99% of the microplastics removed, which is awesome. But again, operational conditions of the plant, the microplastic type, your unit processes all impact the removal efficiency of microplastics. And so this is not a universal, this is what you're going to get if you have these processes, but it gives kind of a basis of what type of unit processes have good removals of microplastics. One last thing to mention with conventional treatment, you see a little bit less removal of microplastics in secondary treatment compared to primary. That's since the mechanism is pretty much the same. You're removing similar types of microplastics. So by time the microplastics reach secondary treatment, a lot of those that are getting removed in primary would have gotten removed in secondary as well. So that accounts for the slightly lower percentages there. So now we can look at advanced stages of treatment through tertiary or filtration treatment. So tertiary treatment is the most reliable in ensuring the removal of microplastics, since these treatment processes are already focused on the removal of generally small or difficult to remove contaminants. Advanced treatment is necessary to remove these small microplastics that weren't removed during our conventional treatment processes, but the removal still depends on the pore size and the microplastic properties. We can see anywhere between 4 and 9% of additional microplastic removal through these processes, but membrane filtration has been shown to be the most effective removal, depending on the pore size of the filter, which directly impacts the removal efficiency of the membrane. Visually, this makes sense. If you think of the pore size and the shape, you can think of this kind of like a sieve. If you know the size of your microplastic and you know the size of your opening in treatment, you can estimate pretty well what's going to get removed. So this is true for both screen filters or depth filters. So membrane removal is effective and works great. However, it can be pretty costly. So things like disc filtration and sand filtration are also very effective. Disc filters depends on that pore size. However, there has been some studies showing that a large amount of polymer addition was needed in some cases to make sure those particles actually kind of agglomerated and were able to be removed by the filters. This high polymer addition caused frequent membrane fouling, and there was also some concerns with backwash pressure pushing the microplastics through the filter or flexing and damaging the filter. Sand filters are extremely effective. They can remove up to 99% of microplastics, but the big concern here is fragmentation. So as that microplastic hits the sand particle, the microplastic, if it's softer, depending on its properties, can break apart and then easily move through the depth filter. Dissolved air filtration is another one I'll mention, and with this, you specifically remove the very small or lightweight microplastics. As they touch the air, they easily float and get removed in that with the skimmer. So here we have some removal efficiencies for our tertiary and filtration treatments. There was a lot of variability throughout the studies in tertiary treatment. A lot of this has to do with characterizing and identifying very small microplastics. It becomes more challenging as they get smaller. And even things like biologically active filtered baths or lagoons sometimes aren't effective in removing of microplastics. And so every treatment plant's different. And this is a place where pilot studies or more lab identification of microplastics could be really beneficial in understanding the removal of microplastics in these types of unit processes. So now we've captured our microplastics in our sludges and our scums from primary, secondary, and tertiary treatments. So as they're removed from the liquid streams processes, they accumulate in our solid streams, and now we get to address them in our biosolids. So if you look at the top 4 pictures, 9 through 12 there, these are examples of microplastics that were found in wet sludges. And the bottom 4, 13 through 16, were microplastics found in soils. So after land application of the biosolids, the soils were tested and these were found. So it's been shown that landfilling and land application of microplastic or of our sewage sludges is spreading microplastics throughout the environment. So what can we do about it? Our solids processing techniques that are already happening at treatment plants or in research have shown some promising alterations to microplastics. The first one I'll mention, though, dewatering, actually kind of has the opposite effect. When you dewater your solids, microplastics that are entrapped in those solids can move back into the liquid stream and be returned back to the head of your plant or wherever that centrate goes to. So kind of a reintroduction to the system. But techniques like pyrolysis, thermal drying, lime stabilization, digestion, a lot of these are already happening on our treatment plants, and they show modifications to the surface of our microplastics. So the top row of images there show a microplastic in a raw sludge. So as you expect a plastic to be very smooth, not much going on the surface, but then as you put it through these different processes, lime stabilization and thermal drying as example images here, you can see like the blistering, the flaking, the pulling apart of the microplastic surface. So we're having some modification of the surface of microplastic through these processes with changes in pH, temperature, mixing, things like that through these processes. To me, this is a little concerning with how much research is out there on the absorption of contaminants to microplastic surfaces. Is this increasing our surface area where we'll get more of that adhesion of those compounds that we're worried about? Or is this destruction helpful in the degradation of microplastics in the environment? This is a little hard to say. This is somewhere where knowing the risk and exposure of microplastics to human and environmental health is going to be helpful in understanding how much and what we need to do in terms of removal and destruction of microplastics. If just going through these existing solids processing techniques is enough to kind of remove that threat, or if complete destruction and removal is going to be necessary for increased environmental health. So just to wrap up a few things. So treatment, conventional treatment, we're removing 90, a lot of times we're seeing 99% of removal from the liquid stream, which is awesome. And advanced treatment processes can remove up to 9% more microplastics from the liquid stream. We're then dealing with these in the solids processing, and those methods can be destructive to microplastics to a certain extent. More research is definitely needed in treatment removals, and having an understanding in kind of a collective way of analysis and characterization of microplastics in wastewater treatment plants is going to be really beneficial to tackling this problem. So microplastics are considered a main contributor to the global plastic pollution crisis, and wastewater treatment plants are a critical point source for the release to the environment. So sounds bad, but this gives wastewater treatment plants an advantage of removing microplastics before they flow into the environment, and increased education and awareness, thinking about the triple bottom line and how these products that we're using on a daily basis affect the discharge of microplastics to the environment, as well as impact wastewater treatment plant processes and effectiveness of treatment, can all help our communities move towards focusing on the reduction of microplastic discharge, and treatment plants can assist in that. So wastewater treatment plants have an opportunity to prevent and minimize our plastic pollution problem from flowing further down the pipeline. So hopefully this was insightful and you're able to learn something, bring awareness to microplastics, and help you start discussions within your communities about the next step for microplastics. Right now, there aren't any regulations on discharge, but being a point source with wastewater treatment plants, we know that's something that we could see in the future. And so microplastics are a problem that we have to work on attacking together in the water industry. So love to hear any questions or if your communities have had experiences with microplastics through school studies, or you're having issues at plants, I'd love to hear that feedback as well, just kind of help grow this presentation too. And feel free to reach out to me anytime. So, thank you.
Thank you, Christine. So yeah, I have a few questions. Do we know, in terms of trends in influent, are microplastic concentrations going up? Are they steady in sort of, say, an urbanized area like we're in here? Or, you know, what's the trend there? I mean, year after year, does it seem to be increasing, or do we have an updated to make a trend out of what we know?
Sure. With this being a fairly new topic, I haven't seen any studies in literature kind of showing a year-to-year change. Right now, the focus is on kind of characterizing and seeing what removals are. Not to say that there isn't a study out there that shows those trends, but definitely something to think about with kind of external efforts to remove plastics. Hopefully that's reducing our microplastics, but again, your social factors really play into that recycling, waste management. How much education is being focused on in the communities to reduce plastic use is a big thing as well. In areas with industries, are those processes changing throughout the years? Are they aware of microplastic release? And hopefully things like the Microbrad-Free Waters Act will help reduce microplastic use and distribution. But even things like that aren't completely removing them from our systems.
Yeah, and of course, you know, that background trend would be useful in letting us know if those bans and, you know, sort of like, you know, public awareness of this item were having, you know, we're having a positive effect on whatever that background trend would be. So yeah, and one other thing, you were noting that we sometimes get sorption of, you know, our PFAS and PFOS to the surface of plastic, but where some of these plastics themselves are constructed out of PFASs, like PTFE, et cetera, is itself a PFAS. And so this may be, I don't know about, you know, what percentage of PFAS in our wastewater are related to microplastic, but it's not, I know it's not zero. So,
Right.
yeah. Okay, let's see what other questions we have for the group. So I'm asking any questions out there for Christine on this microplastics issue. And Christine, I thought the monster blinked at me for a moment when it was on full presentation mode.
Yeah. Yep. And you know,
Oh,
he's
it did.
happy here being in the wastewater treatment plant, and then we talk about removing him and he gets a little sad. So
So one of the things, do we, in terms of partitioning these, I know we partition them by mass, but do we also have data on, you know, how many, you know, we have these kind of, I'm thinking about polygons and polylines, but, you know, we have these sort of polyline ones, the threads coming out of clothes, and then the other, is one predominant over the other in terms of the total volume of microplastics? Does one of those dominate?
yeah, so one of the slides I had a pie chart showing the different distribution in sludges and in liquids. So in your liquid side of wastewater, we're typically seeing fragments, broken down pieces, kind of this, you know, jagged bits. And in the sludges, a lot of the times those are fibrous materials. So like if you're going to wash your clothes and a little bit of fiber comes off, that'll typically end up being in the sludges. So those are the majority are split, but all types of microplastics are found in both the liquid and the solid sides of things.
Yeah, it's eye-opening when you check your clothing, like how little of it is made from natural fibers. Just on a sort of an anecdote, I know that there was I think it was Patagonia or somebody had refused to make a custom jacket for an oil company because I don't know if you heard this story, but they said, you know, well, we don't want to be associated with an oil company, and the oil company give them an award for being such a great customer, pointing out all of their clothes were actually made from their product. But yeah, it just shows how insidious this is, that it's kind of everywhere.
Yeah, and I'll mention one of the harder things with the characterization of microplastics is when you're looking at such small pieces of material, determining if it's a microplastic or a natural fiber, they look very similar in some of these studies, and it's hard to tell. So that's where more kind of standardized method on characterization is really going to help narrow down what we're actually seeing through the
Yeah.
treatment process.
For sure. So I know the big question that I think always gets here, we look at those treatment levels at treatment plants and it looks pretty like we're being pretty effective.
Right.
But removing that material in our sludge, now we're removing it off site, putting it on agricultural fields. And, you know, obviously we're going to have some worries about how mobile they are in those locations and if they have human health impacts or environmental impacts at that site. Any words of wisdom on what you're seeing in the literature for that?
Not a whole lot yet, other than, you know, it's moving into our solids. And I know there's been some studies and research and, you know, master's topics on microplastics moving through soils and into groundwater or running off or even being uptaken by plants or like worms. I haven't dug too much into that. I've stayed on the wastewater side of things, but
Sure.
I know that material is floating out there, or will be published here soon. So definitely a topic where a lot of studies are happening, but not a whole lot of kind of understanding quite yet of what to do about it.
Yeah, it kind of feels that those are going to be pretty pertinent for how we manage items at the moment, depending on what they find there. Yeah, and I guess just thinking about, like, I certainly know I've started to pay more attention to what my clothes are made of, and have tried to start moving towards natural fibers and such. It's just everything's made of plastic clothes. When you start thinking about it like that, they lose some of their functional charm.
Right. Even things you don't think of as being plastic can be plastic, which is crazy.
It's a little troubling. Well, with that, Christine, thank you so much once again for stepping in short notice to give us this. And obviously this is right in our wheelhouse in wastewater management and the wider impacts on the environment. So thank you very much. And we can't give a round of applause for you and Greg on this format, but I'll do it for the group. Thank you both very, very much.
Thank you. And anyone feel free to reach out anytime with more questions or comments or concerns. Happy to talk about.
Thank you.
That was terrific, Christine. Thank you.
Okay, Dave, so we'll go into our business.
Yep, sounds good. On to the special conditions.
Yeah. Okay, so as you know, we've been signing MOUs with members who have taken the extension. This was the additional 3 years where they would continue to pay into the special conditions fund, and then push the removal of phosphorus out a further 3 years into the future. So we were putting together MOUs with every one of those. We have it with everybody now, bar County Public Works, and we're in the process of getting that signed. Just a little bit of back and forth and getting the wording right. We're also renegotiating our we have an agreement with MWRD, which comes up at the end of the year. We're renegotiating that to include perhaps some additional funding. In other words, that they would be moving into the extension as well, and that would be that funding would be allocated again to Fullersburg Woods. So the two bits of funding match up very well, and obviously we'll have an update on where we are with Fullersburg Woods as we move into that part of the agenda. Other items that we've been working on in terms of permitting is Elmhurst wanted they're like about 2 years out sort of from the pack, as it were. And they are taking the extension, but they wanted to us try to get some sort of assurance from IEPA that they were not going to find the door to the extension shut when they got to that point. And we've asked IEPA to help provide some materials to that end. We've also then looked at putting together MOUs with our the non-extension group. They stayed on the original special conditions, and so they're moving into removing phosphorus to 1 milligram per liter. We had a request from Glendale Heights about they were worried that they were going to, by not taking the extension and not continuing to pay the assessment, that somehow the NIP, et cetera, would not be written up to encompass them, and it was in their permit. And so, you know, we give them a letter assuring them that was not the case. but we're looking at putting together perhaps something more formal with them and the other communities. There's about 5 communities that moved to the phosphorus reduction. And again, this phosphorus reduction versus the extent paying into the special assessment of the watershed plan, these are both aspects of improving the watershed. It's just we look at the cost profiles for each individual agency and they make a decision about which one is the most cost effective for them. So the special conditions was always set up as trying to give the maximum amount of flexibility to our wastewater treatment plant members to meet their permit conditions while optimizing the improvement in the river. Chlorides. Chlorides were removed from both the Bloomingdale and the, well, in terms of limits or additional sampling were removed from both the West Chicago and the Bloomingdale permits. Continue to work with members on chlorine. And lastly, came to our attention, thanks to Sue Barrett on the board, that ECHO continues, the ECHO database continues to show a lot of violations for area wastewater treatment plants, including some for the special conditions. This pops up every so often, you know, files or reports that are filed, et cetera, are then not shown on the ECHO database. So I have put a call into IPA about getting that addressed. They've always been very good about tackling those items and getting the database up to date with the actuality of what has been completed and reported. Lastly, annual report, of course, filed back in March 25. We'll look to see if it may be of assistance. We were told it wouldn't help if individual members submitted things like the annual report. And obviously we were just trying, it didn't seem to make a lot of sense, but that is perhaps one of the things that is causing ECHO to record that things like the annual report were not filed. So we'll investigate that and advise members based on what we find. Okay, physical project update. Faywell Dam. Once again, this is the project to, as you know, this project has had 4 different iterations, and the iteration that's closest to success is this placement of this modularized fish ramp ladder system through the eastern culvert on the structure. And so it would be 2 pieces. One would be piercing the bottom lip at the bottom of the splash pad, and then another one would be moving through the main culvert. Essentially, this system allows eddies of water to form inside it that based on another fish, or the same system on the Eel River, looks like it would pass all of our fish species that are downstream. We have an MOU, which was written up in conjunction with County Stormwater, who are the owner of the structure. And that is currently under consideration by County Stormwater. If that MOU is accepted, there's still a little bit of cleaning up to do on it. But it allocates things like who pays for what, who oversees what. And thankfully, County Stormwater has agreed to act as CM on the bid to place the ladder into the culverts. And you know, that kind of thing is spelled out in the MOU. If County Stormwater, accepts the MOU, obviously we're going to have a little bit of tweaking of language stuff. But if it's accepted and formed, then it would go back to the projects committee. And if all parties are agreed, we would sign it, and then we would move on to getting the project permitted and the ladder itself purchased. Okay. Also, a big part of this project is going to be post-project monitoring, and we're working out exactly what that's going to look like. It'd be nice to have some data directly from the ladder itself, that species are passing it. This project's this ladder is tailored to the Faywell Dam site, but it's still it's a bigger unknown than adjusting the culverts, and obviously adjusting the culverts in this project was found to not be acceptable at the site. There's still, this project carries a risk with it that we don't see in our other projects where we just remove the structure because the chances of success in getting fish passage are 100% there. But with this, I think that this is the technologically and in terms of analysis, the best shot we can get at passing fish at the site, but there's just a larger risk with it. And I just want everyone, to be aware of that. All right, moving on then to Growy Mill Dam. This is the Fullersburg Woods site. I'm going to turn over to Dina to talk about this one. Dina.
So I have a couple slides just because we got a lot going on and it was easier for me to work from slides and show you and remind you
Yeah, we needed
everything that I had
to
to talk to you
Give
guys about.
memoir here.
So as you guys know, with Floresburg Woods, we are in the final design, bid construction, permitting side of things. The final design is pretty much complete, waiting, and we're working on mainly focused right now on all the permit solutions submittals. So in the last couple of weeks, we have submitted. The way that the process works, as you guys remember, MWRD is going to serve as the letting agency and the general like CM for this construction management for this project. And they have a crew over there between their stormwater unit and their construction unit that's going to work on helping us get this project out. And then we'll also facilitate the on the ground construction and data and tracking of the project once we go under construction. So as part of their process, we had to submit 98 plans and specifications to them that also included a construction schedule and a project cost estimate. We got those in earlier this week. So that'll go through the MWRD normal review process. That is mainly ability focusing on making sure we meet all the requirements within the volumes of specifications and things like that that are specific to MWRD, as well as reviewing the general construction plans, not for like the riffle needs to be 5 feet longer kind of thing, but more of like, is constructability covered in the plans, and they're not seeing anything that they know from their experience. They're not going to really go into super critical design questions because they've been part of that process, but this is kind of facilitating their review, because then once this review process is complete, then the plans can be finalized and put out to bid. So one of the things from that I think you guys would be interested in is an estimated project cost. The estimated total project cost is about $5.9 million. But that also includes around $900,000+ of alternatives that we're putting in there to back up in case we need them during construction. So the original, the 5.1-ish, $5.5 million covers the cost of the project like as designed, but we're also including extras such as some additional rock and boulders and things like that to help us in case conditions change or different unforeseen circumstances happen during construction. We also have plantings and stuff on a schedule that kind of give us a lot of plants, and our management plan is to see what comes up, because a lot of these areas are wetlands and things like that. So once we remove the invasive species, we don't have the plan set to, plant X number of plants per acre. It'll sort of be based on what we see as we move through the process in order to meet the permit conditions. Permitting is going great. We have permits into almost all of the folks that we need permits from. So the big one is the Section 404 and Section 106 permits with the Army Corps of Engineers. That project was submitted a couple months ago, and we keep getting requests for additional information and going back and forth on that process and answering the Corps' questions. So far, nothing has been brought up to us that's super alarming. A lot of it is just asking for additional information and clarification, but it seems like they are on board with keeping with the nationwide permits for the project. There are several. It's all listed out in the minutes for you. I won't run all the numbers here. And then the Section 106 permit has just gotten kind of started, and that's the permit we need because the dam was built by the CCC and is part of a historical area by being near the mill. And that process will be done between the Illinois State Historic Preservation Office as well as the Army Corps of Engineers, with the Corps leading that process. There is a public outreach process that goes with that. A letter was sent from the Corps to a lot of the potential project stakeholders on the 22nd of June, I believe. That would include everybody from potential Indian tribes that had potentially historically occupied the area, as well as the Mill Foundation and the local historical association and other people. And the Corps will be asking for their input on the project and then going forward with how we're looking at that. Usually the outcome of that process is a memorandum of understanding between the project and landowner, so the DRSCW and the Forest Preserve, with the Army Corps and ISHPO, and we'll say what sort of mitigation opportunities are that we're providing by the removal of the dam. And we have built significant mitigation options into our design plan by including signage, by the work that we're doing in the mill race, by putting a water connection in there so the mill race will retain water. We're adding the motor to the water wheel. All these things will be part of that MOU, as well as the Forest Preserve's continued programming out at the site on the historical significance of the site would all be part of that MOU. So we think that the process it will have this public input process. We do have a lot of mitigation built in, and we should have a successful opportunity of getting that 106 permit without too many significant changes or anything jumping out at us at the end. The DuPage County permits are either being submitted or in process of being submitted. We are having a small issue with some of the online electronic submittal systems with DUDOT, but the stormwater management permit is in and under review. The DUDOT permit is finalized and halfway submitted to the process. We keep getting an error message at one of the screens. DC building and zoning is in. The DuPage stormwater conservation permit is in. The floodplain permit with IDNR OWR has been submitted, as well as the dam safety permit with IDNR OWR. The only other permit application that does still need to be worked on and completed is we'll need an road access permit, because we'll be using Spring Road, which is the Village of Oak Brook property, because our main construction area is on one side of Spring Road and some property owned by the Forest Preserve, and the project is on the other side of Spring Road. And we're working with our contacts over at the Village of Oak Brook to find out what the steps are for that process and how to go through with that permitting process. So the one thing that comes along with all of these permits are permit review fees and permit fees. And so these were all very much detailed in the agenda. And so this is sort of a summary slide of what these permits are. So we're not expecting any fees from the Corps. They have not assessed fees to date for any of the 404 or 106 work. DuPage County Stormwater has submitted an invoice for us for their review, and it's right there for $16,920. Now, the next group of permits, I, along with staff from Hay and Associates, have gone through the scheduled fees that are posted on websites or sent to us and made available to us for how you calculate what the review fees are and I've estimated some of these. So all the ones that are in italics are estimated, and they're also padded a little bit I added a couple thousand or a couple hundred, because there was we weren't quite sure how they would take and review certain things like that. So you can see DUDOT's around 1,800, building and zoning at 12,000. DuPage has invoiced us at 9,700. The floodway permit has been complete because they have delegated the review of that to Stormwater. So it was a $230 application fee, and then they delegated it to Stormwater, and Stormwater will be doing that as part of their review. Dam safety, we're estimating around 28,880. And the Village of Oak Brook, I just said, hopefully it's similar to DUDOT. And these total 45,330. Some of these numbers are a little different than what was proposed in the agenda, but it will be updated in the minutes, because DuPage, we had an estimate for you in the original agenda, but then I got the final and it was higher because I didn't calculate something for 2 years because I missed a slight thing in there. So we're looking at 45,330 approximately estimated on those fees. Now, the way we're looking to help pay for these fees is to be using some money from the contingency funds, and then they'll be recorded as expenditure under the Fullersburg Woods for the fees. So right now, in the budget that we had presented to you guys in February, we had $150,000 in the contingency fee. We've allocated a little bit of that money for other projects right now. You can see that the East Branch additional survey was 8,640. The master plan, in the last meeting, we had to reallocate $10,000 to some additional indirect wetland analysis. And then, as explained in the agenda that Stephen will talk about next, we had a slight increase of about $1,700 for the Springbrook sampling because of travel costs and being increased with the gas prices and whatnot like that on MWRD, on MBI side. Sorry, all the M's just come out. And so right now the remaining balance that the board approved, so the remaining balance in that contingency fund is $129,641. And we would like to request staff, I know I had around 45,000 on the previous slide, but we want a little bit more buffer. I talked to Stephen just so that we're not coming back asking the board for a bunch of smaller increases. If we could get approval for up to 50K for the master planning permit fees, and that would have the remaining being at 7, the contingency fund would still have a little less than $80,000 still in it for other things moving forward.
And again, the contingency fund was put into the budget for exactly this kind of expansion on these projects. We don't know how much permits are going to cost going into these, so there are known costs such as the contracts we sign with consultants, contractors, and such. But the permit fees are a relative unknown. We just know that they're going to not be zero. So
Right, and Stephen and I had talked about this, so I would put it to the membership to make a motion as stated to authorize up to $50,000 for the permit fees for the master plan of Salt Creek at Fullersburg Woods. The monies will be taken from the contingency funds and recorded as expended under the Fullersburg Woods dam removal line item for the repayment of permit fees. So if we can have a motion to that effect. I'm seeing a bunch of people. Sue Barrett making the motion and Tom Menard seconding. So thank you, Tom and Sue.
I have a poll. Hold on. I have like 1,000 screens open right now. Give me 1 second. Thank you.
While we're
And why-
waiting, I want to say how impressive Dina's project management skills have been. There's so many moving parts on this, and so thank you for all the sleepless nights you're putting in, Dina.
Yeah, and if anyone has any questions on any of the permit applications, I tried to detail the individual, in there for you. You can let me know. We did have a question about if the local historical society has any comments or suggestions. Could we share those in the future by email or on the website? I will let you know when we get those. Like I said, that whole process will be coordinated by the Corps. It is a new process to me. I've not been through that process in detail. So I know that they will have meetings with these agencies separately without the applicant there, and then we'll be brought in at some point to be caught up. So yeah, we'll definitely keep everybody in post on all the feedback that we're getting and how that impacts any changes that we have to the project. And thank you, Kelsey. So it looks like it has passed with 3 abstentions. So I appreciate that. And
Thank
I
you.
don't know if we have, I think that covers pretty much everything we are on Fullersburg. Like I said, if you have any specific questions on any of the permit applications or the project at where it is, let me know either via email or you can put them in the polls or chats. But I think that covers all the highlights of what I've been doing on Fullersburg.
Thank you.
Once again, we make extra special effort to make sure that the staff at Oakbrook are informed about all of these increments. They are on the projects committee, but Dina and I always make sure that that we reinforce any information that we have, that they get it as quickly as possible, and we're always available to them if they have any questions.
And I have submitted to them the core permit plans and offered up the county permit application. And I'll send them a link to the final design plans. The final design plans are thousands of pages in case they want to design one and that, but the core permit application had most of the highlights of the project in that and answering any of their questions. So why they are not a review agency for us, because that's been delegated to the county for everything, which is why we're going through county building and zoning and things like that, and not Oakbrook. The village of Oakbrook is well informed on where we are with the project and what's going on.
For anyone who may be getting questions from your friends, neighbors, colleagues, and so on, we are keeping the restoresaltcreek.org website up. So that's a great source of information just to make sure that you're bringing people along with you.
Yeah, and I should point out, I've had a number of concerned citizens call me who were very supportive of the project. I know that this project has its detractors, but it also clearly has supporters. Okay.
The Forest Preserve is preparing for like when construction gets let and things like that. But I've been working with staff over there to provide them all of our background information, and they'll be creating videos and releases and press releases on their end as well as a project partner as we move through this process.
Thanks, Dee. Okay, Springbrook Phase 2. As you know, this is in the post-project monitoring phase. At the last membership meeting, we had been authorized to negotiate with MBI up to $11,000. That contract came in at $12,718.28. So looked at this very carefully, and it was largely due to mobilization costs. In the past, I had based my budget estimates off, prior projects of this kind. And what had happened was, because we don't have a bioassessment this year, it's costing more for MBI to get out onto the ground, because those sort of mobilization costs were typically in the the larger bioassessment contract. And because we don't have them this year, then they're lumped into this smaller contract. So, and then of course, the additional thing is there was some inflation impacts on the budget, but the lion's share of this was these additional mobilization costs. So I have asked the board about this, and they have agreed. But as we had a membership meeting coming up, it seemed this should also be brought to your attention. So this contract amount is being signed with MBI, and it will be the additional expenditure once again coming from the contingency, and the additional expenditure will be shown under the Springbrook project line. Southern East Branch enhancement. The additional survey that we had cleared at earlier meetings has been carried out, and Interfluve were happy with the additional results. Did feel that it was it has definitely increased the accuracy of our project design. So the other items there is that we, Interfluve had wanted this, and it's been something we've been playing around with in the IPS tool, which was we have all of this data, interspatially and temporally in depth, and that we, was there a way for us to predict what was going to happen to the IBIs at the site post-project. At dam projects, this is typically very straightforward. I look at what the IBIs are 2 miles downstream of the dam, and then project that that's going to happen in the basin, the old impoundment. So it's you need the data to be able to do that, but there's not much analysis really required. I think Steve Pescatelli had also noted that people were astonished that we could do this, but he said it's really straightforward. But at this particular site, there is no dam removal, so we would be looking at more the predictive capability of our data to assess as we increase QHEI what would happen to IBI. So Ed Rankin and I had worked on plotting this data and running fit lines through it, and we had come up with a relationship that then, well, obviously we knew there was a relationship there, but we sort of more quantified that relationship, and that is going to be integrated into the report. This is something that Marty at Interfluve really wanted to try to build into the analysis. We had done monitoring at 11 sites throughout the project area last year. We don't have them. We're not doing that this year. And then the last item is, of course, that this project is, it has been put on the the Section 206 Aquatic Restoration Program list of projects for 2023, meaning funds would become available in 2022, October of 2022. Yeah, obviously this would be a huge financial shot in the arm to that particular project. Army Corps is very happy that we've already got all of this IBI data and project design already put in place. And staff will continue to work with them and see where this goes. If they were to take it over, we would have still be having to spend some matching funds, though there are other possibilities there in terms of staff time already invested, staff time in the future, and of course the property value itself can be used as match. But we'll deal with all that once it's clear that the funding is forthcoming. This funding would be for reaches 2, 3, and 4 in the current plan, which is essentially the areas downstream of Royce Road through to Weber Road. All right. Moving on then to Klein Creek. Greg, you're still with us. Do you want to report on this section? Don't mean to hit you up cold on it, but.
Well, that's fine. I mean, as far as section 1, we've got a schedule from Earthworks, who is going to be doing the projects, and they're going to be starting with mobilization and tree clearing in beginning of August. So other than that, we've been talking about retaining wall product and getting that manufactured, but that's the section that's non-DRCW, that's the village. Other than that, section 3, which is the other section of Klein Creek, that this DRCW funded project is allowing us to do, is nearing completion, and we're hoping to put that out to bid just after 4th of July. So it's going to be a busy season.
Thanks, Craig. All right. Moving then into, let's move on to number 7, nutrient implementation plan. So obviously the core of this is our qual model update. Our contractor here is Tetra Tech, and we had a presentation, I believe it was at our last meeting. We had a presentation from them on the modeling to date. Since then, what we've been trying to do is to continue to refine these models and look for any sort of optimization that there may be in there. So set out here in the other scenarios part of the qual model update, which is the 1, 2, 3, 4, 5th. It's the 5th black bullet in this section. We set out a number of scenarios. I'm not going to go through them all, but what we're a number of these items we're looking for is it possible for treatment plants, larger treatment facilities, to perhaps do more phosphorus reduction and then create some breathing space for the smaller plants where phosphorus removal would be more expensive. And just given the size of the investments involved here, it seems prudent to work through all of the any possible efficiencies that we can gain there. So we're currently working on the upper basins. That's the upper part of the DuPage, and then Salt Creek, of course, itself. And the reason we're not, the lower DuPage would be based on any of the outcomes that came out of the 2 branches that feed into it. So as you know, at the May 9th meeting, we had, or rather May 9th meeting of the project committee, the executive and the executive board, both those entities have amended to allow us another $10,000 for additional modeling, and that money itself will be coming out of the once again out of contingent or out of the NIP budget item, and then moved will be shown as expenditure under the Qual 2K budget. Dina, anything else on those items?
Not on the Tetra Tech Qual 2 stuff.
So once again, the plan here is, we are using the target concentration that came out of our IPS statistical analysis, where we find that streams, a significant portion or percentage of performing streams in our data set who were meeting the general use life condition, in other words, supporting bugs and insects to the level that allowed us to meet the general use standard, had concentrations at between 0.11 and 0.28. So what we are looking to do is to check how we can get the major contributor of total phosphorus in our waterways, of course, our wastewater treatment facilities, and how we can get them optimally set up to move into getting our stream warm weather concentrations down below 0.28. Okay, non-point source phosphorus feasibility analysis. We had a presentation on this earlier on in the year. As you know, this was documenting what we're capturing from leaf litter pickup and street sweeping. And we noted there was a couple of entities that had not replied. It was actually just some, a couple of them hadn't been properly notified, and we are working with them. I talked to the tollway yesterday. They're going to be completing it, and then of course DUDOT is also in the process of completing it. It just, they were missed during the notification process. So those totals will be calculated for them and then added to the aggregate total. We also have some smaller communities that had not responded. It's possible that we will, I don't know that we'll be getting responses from them, but it may be that we can generate some sort of average removal if we can at least get confirmation that they do some form of street sweeping, et cetera, that we can get some sort of median or mean removal rates and add their surface area in, explicitly stating that we don't have direct data from them, but this is an acceptable. We think this is an acceptable way forward. Expanded DO monitoring. Dina, anything to report on that?
No. We're not monitoring this year.
Yeah. Well, we have a little bit that's sort of
that's coming later.
Yeah. IPS model, no update on that. Obviously, as I don't know if I had said earlier, but our colleague over at MBI, Ed Rankin, had been quite seriously ill. I'm pleased to report that he seems to have made a full recovery. That has been holding up some of the reports that MBI have been working with us on, and he was supposed to also carry out training on using the IPS data set. That has been suspended for the moment. I want him to finish a number of reports before we get it back onto the calendar. But we're working, that is us and Lake County, and I know a number of members that also expressed interest in taking part in that. Okay, let's move on to the bullet additional NIP tasks. So it's been clear, something that some folks on the board and staff have discussed quite a bit, is that one of the items that we were missing in our IPS analysis was a full accounting of the relationship between dissolved oxygen and aquatic life. And this is because, we run our IPS on the, our bioassessment data and IPA data, and then we also have our partners in Lower DuPage and Lake County who also supply data to that. But not all of those sites have continuous dissolved oxygen data sets. And if you work with dissolved oxygen, there's a world of difference between the continuous data set and the discrete grabs that we sometimes use for dissolved oxygen. They're not really very informative. So what this contract is a contract with MBI for them to develop essentially the IPS methodology for dissolved oxygen data set. Now, total contract is coming in a little over 35,000. Which, and obviously our IPS tool cost in the region of 120, 130,000 for all of the parameters, but the data set for dissolved oxygen, while it's more limited by site, is large. I mean, we have, 15 years of dissolved oxygen data for a number of sites. We've also accessed IEPA data to go into this, and we also have some data, I believe, from the Lower DuPage, which would also be relevant. So that dissolved oxygen data, there's a lot of ways to look at it, in terms of, what is its mean daily, mean, what is the DO fluctuations, etc. All of those things need to be taken into account. And what we would look at is pulling out thresholds for each one of those characteristics: minimum DO, maximum DO, daily fluctuation, etc. So we develop our sensitive species list for those, and then also develop what we think those correspond to in terms of meeting the general use aquatic life. This is important because, as we saw in our section, we are aiming for this threshold for phosphorus, and it does not totally eliminate our dissolved oxygen issues on our waterways. And that's because the dissolved oxygen issues on our waterways are not totally due to nutrient loading. They're also due to a number of physical characteristics. And so we want, when we're moving forward with our NIP plan and we take it to the state and our environmental partners, we want to be able to account to them for this relationship with dissolved oxygen more fully, and be able to complete our argument on why we think that the concentrations of total phosphorus that we're putting forward are going to be adequately protective of aquatic life, and that they are not triggering dissolved oxygen impairments. And those dissolved oxygen impairments, while they will not go away, we will continue to work on them, but they're not going to, it removes the phosphorus DO link and allows us to fully explore that and show that to the people who are looking to bless our nutrient implementation plan. Now, this research is obviously not just of interest to us, it's also interest to a lot of our partners. So one of the other watershed groups that formed after the DRSCW, this is the Lower Des Plaines River Watershed Coalition. Did I get that name right, Dina? Lower, I always get confused about
Lower Des Plaines Watershed Group.
Yeah, it's okay. So they had a meeting to discuss this. I presented the necessity of this data and this analysis, and they have agreed to fund up to $25,000 of the total contract. Now, obviously, they're putting this forward because they're using our IPS work quite extensively, which they did not fund. So they see this as helping, push this research further forward into this important area, as they're benefiting from a lot of the investments that this group made during the last 10 years. So that would leave us with $10,000, $10,753.12 in the contract, which is purchased. So the board has already authorized 10,000 in this, but as the contract, which I pulled together, doesn't kick off until tomorrow, it seemed that this should be brought to the general membership to vote on the total amount for the totality of the 10,753.12. The way this project would function would be that Dina and I would manage it. We would spend up to 25,000. That would all be then passed through from the Displays group. And then after that 20,000 was expended, then we would move into the DRSEW fund. So they wouldn't be partitioned out on a sort of a 2-to-1 basis or something like that. So we'll have an MOU with them to set out that methodology, but that's what has been agreed. So with that, Dina, I think we have a vote on this.
Well, yes, but you wanted me to kind of explain how the monies are being spent. But it also includes the next reference site analysis. So you want to go through that since it's tied to this study, and then I'll go through the money and then the votes, and we'll have 2 votes.
Sounds good. Yeah, so what Dean is talking about is that, once again, just showing you how this affects our NIP budget item. So the second item in this is that we had also wanted to increase the amount of data that we had from sites with minimal modification. So these are the reference sites that you've heard us talking about. We have gathered some continuous DO data from those sites, and also done our expanded DO data set, which looks at the physical characteristics in detail at the site, such as, and includes flow, benthic algae, etc. But we would like to expand that data set somewhat. Now, as part of that, staff does that sampling, but as part of that, we also need the biological data to go along with it. So we would like to contract with MBI for an additional sampling at the reference sites. $16,000 what we're asking for. They're currently preparing a quote, but based on the prior upgrading cost due to mobilization, etc., this should cover it for the number of sites that we're looking at. This data would then.
Stephen, hold on one second. The 16,000 is budgeted at about 11,000 for MBI for the bugs and fish and habitat sampling, and 5,000 for the additional chemistry, which would include the benthic chlorophyll A. So that 16 includes both, not just MBI.
It does, yeah. So that covers both the chemistry and the biology at the site. And this would, Dina, we can throw up that slide with the costs on it, or rather with how we draw it down. But this 16,000 would be coming out of our NIP budget. As you can see, we've set it out here. NIP budget is currently budgeted for year 22 to 23 at the 201, $90. We've already taken 10,000 out of that, authorized by the board for the additional qual modeling. So here we have, as you can see, we have these 2 items here: the continuous DO analysis, and then we have the 2002 reference site sampling, which is the one I was just talking about, 16,000, which, as Dina pointed out, covers both MBI and the chemistry at the site. This would leave $164,336.88 in the NIP budget. Now, that NIP budget was put together for exactly this kind of item. We foresaw that coming out of our qual modeling and out of the non-point source study and out of the trading, there could be elements that we got to, but we couldn't have foreseen at the beginning of this process. So it is there to support these processes going forward. This, I think staff feels very strongly this continuous DO analysis does need to be done. It is a hole in our current analysis that the more I look at it, the more I feel is a glaring hole, but it's one that we had previewed having to deal with. And I think we're at the point now where we have enough data, obviously supported with this 16,000, that we should get some good information out of this, as well as our, by the application of the methodologies we developed under the IPS. So our motion is to authorize the expenditure. Oh,
sorry, you want that back? Sorry.
Well, I can read it right off.
I can't be sharing and do what I need to do. So there's the first motion is to authorize the expenditure of not to exceed $10,753 $53.12 from the NIP budget to contract with MDBI for the development of the relationships and thresholds for the continuous DO variables, nutrients, and biological attributes in the Northeastern Illinois IPS. It's the longest title ever.
Yes, yeah.
Um,
Doesn't fit into well the boxes and tables either.
so that is the first motion.
And I guess before we do that, is there any questions on, and I'm thinking particularly the reference one, I think is pretty straightforward, but on this this DO study, it has been passed through the projects committee, who give it a pretty thorough going over, and we did have questions on it. But are there questions out there on, what this exactly this would do, or the necessity of it, etc.? Realize it is it's a pretty sizable contract. But again, one that we had budgeted for, it just wasn't being called out in the budget because we weren't quite sure exactly what form it was going to take.
Well, let's go ahead and
Yeah,
take a
go ahead
motion.
with the motion then. And if people have questions about it, please do reach
Sorry,
out to.
I did that too fast.
No,
Sorry.
that's okay.
All right, I've got Sue Barrett making the motion and Larry Cox seconding.
Got excited to do a motion.
Yeah,
We're
I'm
coming-
excited to see what comes out of this study. It's been something for years we've been kind of.
We're just about
skipping at
11 o'clock, so hang
Yeah.
in with us.
Oh, yeah, sorry. Yeah.
We have
So-
another vote after the next one.
So this
uh,
motion has passed with 2 abstentions.
I apologize, Dave. I wasn't looking at my watch.
And then the second motion, I can read it just so that, let me lower hands so I can re-raise them. Hold on one second. The second motion is to authorize the expenditure of up to $16,000 from the NIP budget for the implementation of the expanded DO program at selected reference sites.
All right, they have Dennis Stryker making the motion and Sue Barrett making the second. Thank you.
Okay.
So,
Skip lightly through the agenda and we do need to get to.
to the final staffing contract. Oh, well, the reference site, yeah.
That this motion has passed with 1 abstention.
Thank you. I apologize, Dave. I wasn't looking at my watch.
Oh, no, there was a lot of good information and that was something that needed to be explained. So
Okay.
a little bit late, I hope is okay with everyone, but we do want your vote on this next one.
Yeah. So with that, I'm going to jump to the end, Dave.
Sounds good.
Yeah. So we're going to go to the final page of the agenda under membership dues payments and update, and we got the bullet following that, which is the staffing contract. So every year we have a staffing contract with TCF, who Dina and I work for, which comes up, which covers our remuneration for working on the project. The contract was attached. The amounts match the amounts in our budget. The board has already reviewed it and has authorized us to bring it to the general membership for approval. So the motion, a new motion is needed to approve the TCF contract amount or contract for 22 to 23. The amounts, if you know, look a little different to what's in the budget. And that's because the budget moves out of sync with the contract. So there's some years or some months at a cheaper rate and some months at a higher rate, which explains the difference. But overall, when you look at how it bleeds through into the following year where the contract would run, then those figures add up. I think that's all there is really to say about the contract. So Dina, can we put up the motion?
Yeah, so the motion is to just approve the contract for 2023. And so
Yep,
I
the
think
motion
I
needs
need
to approve
Rick
the TCF
to, I
staffing
need
contract.
Dave to choose his first and second from his hand raised.
I see Rich Salerno and Steve Zahner.
And I will launch the poll.
And that contract will start actually Friday, July 1st. It's written, if you had looked at it, to be attested by Rick, our treasurer. He's out of the country, so I'll ask Sue Barrett as our vice president to attest to that today.
And the motion has passed unanimously.
All right, thank you, everyone. Anything before we wrap up, Stephen and Dina?
No, if anyone has any questions on any of the other items, you can feel free to probably start with me and give me a call or an email, since Stephen's going to be out the country, might be harder to reach. And then if I can't answer your questions, I can direct you to Stephen.
Well, good meeting. And thank you to our speakers, Greg and Christine, for short notice stepping in. We appreciate
Yeah,
it.
really appreciate it.
We can then take a motion to adjourn, please. Steve Zahner, seconded by Rich Salerno. So thank you, everyone. Have a
And then
wonderful
if
summer.
I can ask Sue to stay on for a second, I'm going to promote you to a panelist. I have a question for you. Sue Barrett.
And I will be back in 1 minute.
Okay. Hey, Sue.
Sue, you're muted. Can you talk? I'm trying to see if I can unmute her.
Hey, Stephen, I got a quick chat question for you.
I'm sorry, a quick.
Quick question
you
in
hear
the
me
chat.
now?
I can't hear you now. Hold on 1 second, Sue. Let me just finish doing what I'm doing.
Okay, okay, great.
Stephen, check your chat. Check your
Okay.
chat.
Why am I not? I'm not seeing anything in chat. Oh, I maybe that's what's happening. Yes, I do. Greg, I assume that question was from you.
Yeah. Dina, are you going to keep it recording or are you going to stop?
I'm going to turn that off. I